precedent, that is the Pierre-Regis Nervis mushroom structure, that is composed by a diaphragm. In order to find a way to handle all these things, and in order to develop the project, we created a methodology that comprised 4 steps. The first one is specifying the assemblability constraints, which more specifically means defining the assembly tools or robots constraints. The second part of the methodology is pointing out the geometric and assembly subdivision strategies. The third is finding suitable toolpaths or geometry of movement of the robots in space. And the fourth is creating strategies to handle inaccuracies. So the first step in incorporating the robot is understanding its abilities and constraints. So this is the envelope space of the robot, where the workspace of the robot. And to understand these ranges, what we did is perform several iterative tests in a robot programming environment, and then the result of these tests help us to define the overall scale of the structure relative to the maximum reachable point of the robot's envelope space. The structure dimensions were therefore 1.4 meters high and 3 meters wide. So the second point is this understanding the robot constraint suggested that we could actually build one portion of the structure. So we defined a strategy of subdividing the whole structure in 6 portions, and then each portion will be repeated 6 times. This is handling 60-degree angle, and this is the overall. So this the code for this section will be repeated 6 times.
When we rotate the structure every 6 times, there was a rotary plate that enabled us to rotate it.
So another, sorry, back to the text. So in this case, what you were saying is, so there is this radial subdivision, and then another problem is taking into account the lifting and weight capacity